Yes. Example 4. Step 0. Factor completely. Can you see that the bottom is a difference of squares? Can you see that your x plus 3's will simplify? So if it does simplify, rewrite it simplified. Now, when you simplify something like that, it's actually 1 over 1. So be careful. You're not just left with x minus 3. You're left with 1 over x minus 3. So this one, step 1, when we look at our non-permissible values, we have 2 of them because we look at our original equation. X can't equal negative 3 and x can't equal 3. But we end up with 1 whole and 1 vertical asymptote. So first of all, we're going to have a whole at, well, the x plus 3 is the one that canceled out. That's when your non-permissible value is negative 3. So you're going to have a whole at negative 3, comma, and how did I figure out that this was going to be 1 over negative 6?
Because you looked at the modified equation.
Yeah, we look at the simplified version, and we can plug in that non-permissible value into that simplified version to find out where that whole is. We're also going to have a vertical asymptote at the other non-permissible value. So we're still going to have a vertical asymptote at x equals 3. We always do our non-permissible values first because in step 2, when we go to do, right, step 2 is always your horizontal asymptotes or oblique asymptotes. You're always going to look at the simplified version to find those. Because sometimes after you simplify a whole, you end up just with a line, and then you can just graph it right away. But in this case, we still have a rational equation after we've simplified. So we look at the y equals 1 over x minus 3, and we use that equation to find out if we have a horizontal asymptote or an oblique asymptote. Maybe you can see, because the degree is bigger in the denominator, that you're going to have a horizontal asymptote at y equals 0. Or maybe you want to use that, well, my highest degree is 1. I have 1 x on the bottom. I have no x's on the top. That simplifies to y equals 0. Maybe you want to use that technique to find out that you have a horizontal asymptote at y equals 0. So usually, in almost everything you've ever done with math, you always check your original equation. Okay? With your horizontal and oblique asymptotes, oh, that's spelled bad. Man. You're going to check your simplified equation. Because in example 1, your simplified equation ended up being a line. Whereas if you would have looked at the original equation in example 1, you might have thought there was an oblique asymptote. So you're always checking your simplified equation. Step 3, we'll check if we have x and y intercepts. Y-intercept is plugging in 0 for x. Can you see that when you plug in 0 for x in either of the equations, you'll get 3 over negative 9. Or negative 1/3. For your x-intercepts, again, we're working on graphing the simplified version, and we're going to add our whole. If you look at your simplified version, 1 over x minus 3. Is your numerator ever going to be equal to 0? No. Okay? If you had checked your original equation, you would have said negative 3 was your x-intercept. But negative 3 was our non-permissible value. And when it's simplified, What we're actually graphing is we are graphing the simplified version and adding a whole to it. So we only have a y-intercept at -1/3. So we're going to find out after we graph what we know so far if we need some additional points. We know that at x equals 3, we have a vertical asymptote. We know at y equals 0, we have a horizontal asymptote. And we know that -1/3 is our y-intercept. We also know that there are no x-intercepts. We have enough information to graph this section, but we need to have another point to graph the section where the x values are bigger than 3. So if we plug in 4, again, we're graphing the simplified version. So the simplified version is 1 over x minus 3. Can you see that if you plug in 4 for x, you will get 1 over 1. So we have the point 4, 1. And the last thing we have to make sure we haven't done yet is we haven't graphed our hole. There's our hole. At -3, -1 over 6. So you might have to take out your eraser to erase a spot where you're going to put your hole like I had to do. Or maybe you'll remember to put your hole in before you graph everything.
Could you use that where you did made the equation slightly redifferent, for example, -2, and then you see the overall equation is positive or negative, see it's going down towards the
You could do that as well.
that would have worked
Okay?
as well.
Now, this unit really connects to a bunch of different units. Look at this equation. And if you think about transformations unit, can you see that that is a 1 over x graph that's been moved 3 to the right? And if you remember what your 1 over x graph looks like, notice that that's just here. You would also have a point right here, 2, -1, if you wanted to. It's just your 1 over x graph moved 3 to the right. But now our 1 over x graph also has a hole in it. Typically, on the exam, you will get questions like 1, 2, and 4. They seem to avoid the oblique asymptote on the exam. That's not to say that, who knows, maybe this year will be the first year that an oblique asymptote appears on the exam. But they seem to really like ones like question number 4. Unfortunately, there's no additional examples for question number 4 in your homework today. So just work on questions 3, 4, and 5. But I will give you some more to work on